Welcome to Saturday Algebra 2 Academy. Today we're going to do a full review of the third quarter final cumulative assessments and get your study guides in front of you. Do the work on the study guide. That's why I got you an extra copy so you can take those home. You have an extra copy at home that you can do by yourself and just test yourself to see how you do. Okay? All right, here we go. Number one, it reads, Victor Hack, thank you, appreciate it. It says, graph f of x, the graph of f of x equals negative x squared plus 3 is given. There it is. In class, we actually graphed it, so I'm actually giving you the graph. So all they're asking us is for the domain and range, and when you zoom in, so let's see. Domain, they're talking about the x values. So if you have any graph and it has arrows pointing either down or up, it usually continues going in both directions. That means it's going to continue going to negative infinity and positive infinity of x. So in set notation, we write solution set of x such that negative infinity less than x less than positive infinity. And once again, if you notice, this arrow of the function keeps going downward, but it keeps opening towards the left. This one keeps opening towards the right. That's why it covers all x values. All right, let's do the range, and then we'll get to the interval notation. So the range, same thing, but we focus now on the y-axis, starting from the bottom. Notice that the arrows continue going downward, so it continues going to what? To negative infinity. How about upward on the y? It stops where? At 3. So that means our solution set of f of x such that negative infinity less than f of x less than or equal to 3. Why equal to? Because notice this point on 3, it's included on the graph. Why not equal to infinity? Because we never catch up to infinity. They continue going. Okay? Kind of like, let's see. Oh, like I saw Jay sprinting the other day in the track. He was like jamming. They couldn't catch up to him. He was like infinity. Let's go. All right, let's go to interval notation. Interval notation. So for interval notation, remember, we only have parentheses, which means not included, and brackets, which means included. So since the infinite is not included, we do what? Parentheses, negative infinity, comma, positive infinity. For this one, it has infinity, so it's negative infinity, it's parentheses. How about the 3? 3 is included, so it's bracket. Stay focused, please. And I know some of you are like, Mr. Q, we already did this in class. I already saw it as a video. I understand. But imagine if I asked you to shoot 3-pointers, you would shoot. I would ask you to shoot like 500 of them, so you can get better at this. Hello. All right, let's do end behavior. So end behavior, they're talking about the graph itself. So let me show you the graph without all the background. The graph looks like this. It has one end, which is this one, and it has another end, which is this one. And notice both of them are pointing downward. Does everybody understand that? Okay, so I'm going to first focus on this end, that it continues downward, but it continues opening up. What happens to the x values as this continues going downward and opening up? They keep getting close to what? Negative infinity. So we write, for this end, we write as x approaches negative infinity, comma, as x approaches negative infinity. What happens to the y values? They continue approaching what? No, look at it. Negative infinity. They continue approaching negative infinity because it goes downward. So f of x approaches negative infinity. Now, in the last semester assessment, some of you just wrote that and you were done. But how many n's does this one have? 2. 1, 2. Now we need to do the same thing for the other side. As this n continues going downward, it continues going to the right. Is that correct? So it continues approaching what value of x? Positive infinity. And how about value of y? Negative infinity. So let's write that in. As x approaches positive infinity, f of x approaches negative infinity. Do we have to worry about the 3 or anything like that? No, they're just talking about the end behavior. What is it doing towards the end? Okay, let's go to number 2. All right? It says, a fireworks projectile is launched at 20 meters per second from a 60-meter cliff. The table shows the height, y, in meters that projectile is above a field after x seconds. And they give us a table in t seconds, 0, 1, 2, 3, 4, 5, and height in meters, 60, 75, 80, 75, 60, and 35. It says A, plot the point to make a curve. So let's plot those points. I'm going to use blue for that. So then we got 0, 60, 175, 280, 375, 460, 535. Sketch your curve. There it is. All right. Part A done. It says, what is the maximum height of the projectile? Height. The maximum height, it's right there. And you should have written 80, but not just 80. 80 what? Meters, yes. Yeah, stop shortening your language structure like you do on Snap or whatever it is you guys do. Kick. Yeah? Over what interval is the projectile's height increasing? Height. So the projectile's height is increasing from here to here. Do you guys notice that? All right, so let's start with the height, since they asked us for the height. Height, and they want it in interval notation. Since 60 is included and 80 is included, then we go to what? Bracket 60, comma, 80. However, I do want you to show me the increment, or as it's increasing also, in time. So if you were to give me the time, the interval notation time, tell your neighbor what you would write, please. What would you write there? That is correct. Bracket 0, comma 2. And have you got that? All right. Now that I showed you this one, answer these for yourself. It says, over what interval is the projectile's height decreasing? Do that yourself. Go. All right, check with the neighbor, see what they got. So let's do the height from here to here. We said it was from 80 to 35. Is that correct? How about in time? From 2 to what? 5. Hands, have you got that? All right. All right. Any questions with that one? We're good, yes? All right, really quick, let me introduce Mr. Velasquez. Mr. Velasquez, this is our Algebra 2 students. He's going to be just helping me out. If you have questions, if you get stuck, he's going to be walking around. Just raise your hand, and he'll help you out, okay? Yes, Mr. King. All right, good. Let's go to number 3. It says, describe how to transform. Notice here, look up, guys. It says describe, but we're going to address that at the end. I want us to start with the graphing portion. So in blue, if you have your blue, I want you to graph f of x equals x squared. You don't need a table by now. By now you should be able to do that automatically. Tell your neighbor how, please. All right. Let's see. What value shall I input? Let me ask someone at random. How about Aldo? Which is our first value? -2, and what'd you get? No, -2 what? 4. -1, 1, 0, 0, 1, 1, 2, 4. By now, this should be automatic in your noodle. You should be able to wake up every day, oh, -2, 4. Right? You smell the chorizo with con huevo, and you're like, oh, parabola. All right. Now that we have that, let's graph this one. I'm going to do this one in red. For this one, we do need a table, so I want you to write x. And on the side, instead of writing g of x, I'm going to write the actual function that they give us. I'm going to leave it like that so that I don't get people confused. I'm going to write the whole thing, f 3x minus 1. However, what was the parent function doing? It was a square. Is that correct? So don't forget to put the square on that one also. And which values do I use for x again, Aldo? -2, -1, 0, 1, 2. All right. So, which means I'm going to take this -2, I'm going to substitute that in here and multiply times 3, square it at -1. So let's see. What is -2 times 3? -6 squared is 36 minus 1, 35. Next value, -1. -1 times 3 is -6. Oh, my bad. -3, my bad. Hold on, I think I need another sip of coffee. Damn, that's good. All right. -3 squared is 9 minus 1, that's 8. 0 times 3 is 0, and we're left with -1. 1 times 3 squared is 9 minus 1, that's 8. And 2 times 3 is 6 squared minus 1, that's 35. All right, so what do you guys notice? That we cannot graph these because I didn't give you the graph to fit that. Somebody asked me the other day, do I graph it, Mr. Q? Well, I don't know where, but yeah, you can. But for right now, we're going to graph these three, yes? All right, let's do that in red. So we got -1, 8, -1, 8, 0, -1, 1, 8. Nice. All right, let's answer the question in regards to describe. Describe the transformation. Here goes again what I asked you to do. Whenever you describe, first start describing if the function or the vertex either goes left or right or up and down. That's the very first thing you're going to describe. Tell you never what it did to that function. All right, so the first thing it did, it what? It moved which way? Down. So you write moved down 1 step, comma. All right, now that we have that, we answer the question whether it's stretched or compressed. Good morning. Stretched or compressed, what did it do? It stretched, so we write stretched. In which direction? Vertically or horizontally? Vertically. Vertically. And in parentheses, put the, by what we stretch it, it says by 3. 10 cubed. Yeah. Okay, on the parte, guys, you have to do all 5 because you might be able to graph also the -2 with its value. So don't just go, oh, I'm just going to do -1. No, I want to see all 5. If it's out of range of, yeah, if it's out of range, you don't graph it. But if it's in range, yes, graph it. All right, show me your fingers. How comfortable you are with these? 1 to 5. Yeah, we got these, yes? All right, I know. Squeezy. Let's go to number 4. Graph a given function and identify the range. Let me zoom in. Identify domain and range. All right, let's start with very first thing we need to identify in blue is our vertex. Our vertex. By now, just by looking at it, you should be able to tell what H and K is. Tell you there what H and K is for that one. That is correct. I see that H is here, K is here, so my vertex is 2, -7. Let's graph that. We got 2, -7. And write your pencils down, look up really quick. Be careful on the part take, because if you notice, these are scaled by what? 2s. Some of you go a little bit fast and you think these are by 1s, and when you start using the slope 1 up, 2 to the right, you start going in increments of 2, so be careful. All right, so this is 2, -7, which is right third. All right. Now, do we need a table to graph the other points? No, we just need to use the this factor as a slope. So how many steps? 3 up and 4 to the right. So we go 1, 2, 3, 1, 2, 3, 4. Go back to the vertex again, and we do it again, but now to the left. 1, 2, 3, 1, 2, 3, 4. All right. All we need is 3 points. Before we move on, look up, please. Look up to the screen. What if the function, look up, was exactly like that, but it had a negative outside the absolute value? Tuck it over your neighbors, let them know what it's going to look like. Let's see, let me pick someone at random. How about Kenzie? What would it do, Kenzie, if it had a negative? It would be pointing down. That is correct. It reflects about the x-axis or the horizontal axis. All right. Are we done? No, they want what? Domain and range. For this one, just to go a little bit faster, let's do it in interval notation. Is that all right? Will that be a little bit easier? Yes? Yes, Mr. Kim. All right, good. Domain. Okay. So look at the x-axis and look at the arrows of the function. Will it continue going to both sides? Yes, so my domain is parentheses what? Negative infinity to positive infinity. And we're like, I don't see it, Mr. P. Well, look at this arrow. It's going to continue going upward, but always to the right. That means the x values will continue going to positive infinity. Same thing with the other direction. All right? Let's go to the range. Range. Start from the bottom. Does it go all the way to negative infinity? No. Where does it start? At -7. So I'm going to write -7. Is that included? Yes, so it's bracket. And since the arrows continue pointing upward, it continues going upward to what? Positive infinity. So we write positive infinity and parentheses. Are we done? Yeah, that's all they're asking. Domain and range. Let's go to number 5. All right. It says, solve each problem using an absolute value inequality. Before you answer this one, look up really quick. Let me remind you of the general form of transformations, which is g of x equals a times, what is it? Parentheses, 1 over b, parentheses, x minus h, close parentheses, plus k. That applies to all the functions. You guys remember that? So now, notice inside we have x minus h. That's why when we start our absolute value function, we always started with absolute value x minus. It's pretty much mirroring our transformation function. You guys see that? Instead of parentheses, now it's absolute value. Let me close it. But since it's an inequality and the age cannot be greater than the difference that they give us here, it has to be less than or equal. All right. And once again, as I reminded you in class, I'm going to do something over here underneath the squirrel that has nothing to do with this problem, but to refresh your memory. I remember I gave you guys stuff, again, absolute value x minus 2 equals to 5. And I asked you, is there anything outside the absolute value? You said no. Therefore, at this point, we would do what? Two equations. One for negative 5, and one for positive 5. And then we write x minus 2, and we solve. So which one changed positive and negative? The constant outside. Is that correct? So let's read the problem. On average, a squirrel lives to be 6.5 years old. The lifespan of the squirrel may vary, circle that word, vary, may vary by as much as 1.5 years. What does that mean? Either what? More or, so where do we write the 1.5? Outside 1.5. So that means 6.5 goes right there. Here goes the question again. Is the absolute value by itself? Yes, so at this point we do two inequalities. One for negative 1.5, one for positive 1.5. I'm going to do the negative in red. So 1.5 is negative 1.5. But in order for that to become a negative, what happens to the inequality symbol? It flips. There it is. And we write whatever's inside the absolute value. Let me do the other one in green. This is positive 1.5. The inequality symbol stays the same, and everything else stays the same. All right, let's solve. Plus 6.5 plus 6.5. So we're left with x is greater than or equal to 5. This one is plus 6.5 plus 6.5. X is less than or equal to 8. Are they asking us to graph? No. Are they asking us to write domain and range? No. But they're asking us to write a statement to answer the question. What does it say? What is the range of ages that a squirrel lives? Write it by yourself in your own words, and then we'll share it. All right, share with your neighbor, see what you wrote. Kenzie, pick someone. Ramon, what'd you write? Squirrels life can vary from what? 5 years to 8 years. 10Q. Hands, if you agree with that? Yeah? Yeah. Like I said, in your own words, just make sure to address the ranges that you got. Let's go to number 6. Number 6. Oh, yeah, I like these. On this one it says, solve the equation 3x squared minus 6 equals 6 using the indicated method, by graphing, by factoring, and by taking the square root. And like I told you guys, which one did we say was probably the easiest one? They're all easy, but let's start with square root. So let me write in here, we're going to write 3x squared minus 6 equals 6. Line down the equal sign and make a note for yourself on this one, asterisk. What is the main idea when we solve for square roots? We need to what? ISO what? Variable. That is correct. ISO the variable. All right, let's continue. Demi is here. All right, let's go. Bam. All right, so we need to leave x by itself. So what do? Plus 6 plus 6 We got 3x squared equals 12. What do we do then to leave the x by itself? Divide by 3, divide by 3. X squared equals 4. And my last step? Square root, x equals plus minus 2. These are my solutions. Kehlani had an earpiece. Take it off, please. Thank you. Appreciate it. Yes, I have cameras back there. Tell me how many solutions did we find? How many solutions? How many solutions, guys? 2. Positive 2 and negative 2. All right. Let's go to B. Any questions with roots? You're like, no, Mr. Q, this is a piece of cake. I know. I'm telling you. Let's write it again. 3x squared minus 6 equals 6. For factoring, what is the note that I asked you to write? That it needs to what? Equal to 0. That is correct. So one of the sides needs to be equal to 0. Which side has to be by the easiest one? The 6. So that means we need to subtract 6. Subtract 6. We're left with 0 equals 3x squared minus 12. Now we can factor. You're like, Mr. Q, but it's not a trinomial, so then what can we do? Check for what? GCF. So what is GCF? 3, we're left with x squared minus 4 equals 0. However, things that you need to be looking for in your noodle. If you end up with something like this, what does this look like in factor form? Tell your neighbor, please. That is correct. Make a note. That is a difference of squares. So this is x plus 2, x minus 2. Bring down the 3, and all that equal to is 0. All right, now that we have our factors and that is equal to 0, what do we do at the end? Set each one equal to 0. So we got 3 equal to 0, x plus 2 equal to 0, x minus 2 equal to 0. Is this true? No, we got rid of the BFF by minus 2, x equals negative 2, plus 2 plus 2, x equals 2. And these are my solutions. Did we get the same thing as the other method? We should, because it's the same equation, different method. Okay? All right, let's go to graphing. Graphing. Let me zoom out. All right, for graphing, I want you to write the equation right here. 3x squared minus 6 equals 6. And there's three steps before the graphing portion that we need to do in it imperative. The first one. First step, it has to be equal to 0. So let's do that. Minus 6 minus 6. We end up with 3x squared minus 12, and that is equal to 0. Okay. Step 2. Make it equal to y. Remember, in the original form, instead of being 0, it should have been what? Y equals 3x squared minus 12. And of course, the third most imperative piece for graphing, we need it's a table, right? You guys see it? X, Y. You guys didn't see it or what? Yeah? All right. And which values? Let's see, Aldo. For X. Negative 2, negative 1, 0, 1, 2. All right. So let's do this. I'm going to use red to be substituting values. And once again, do you need to show me work for these? Not anymore. By now, you should be able to do this in your Noodle, yes? So just show me what you're going to do. So here we're going to substitute values in here. So let's start with -2. What is -2 squared? 4 times 3 minus 12, 0. Next value, -1. What is -1 squared? Times 3 minus 12, -9. Next value, 0. 0 squared is 0 times 3, 0, and we're left with -12. Next value, 1 squared times 3 minus 12, that's -9. And the last one is 0. All right, since, who notices that we're going to have a -12 and this doesn't go all the way to -12? Let's do a coordinate plane over here on this side. Is that pretty straight, or? There it is. All right. First point is -2, 0, so we got 1, 2, -2, 0, which is right there. Next one, -1, -9, -1, -9, so it's about right there. Next one, 0, -12, 0, -12, let's say -12 is about right there, so we place our point there. Next one, 1, -9, 1, -9. And the last one, 2, 0, 2, 0. All right, let's graph our parabola. There it is. All right, Mr. Q, I already graphed it, but how do I know the solution? Tell your neighbor how you know the solution of the graph, please. How do you know the solution of the graph? Ramon, have someone? Doc, how do you know the solution to any graph? Yeah, you said whenever it crosses the x-axis. That is correct. X-intercepts are solutions. And what are the solutions? -2 and 2. Wait a minute, that looks like a dog, doesn't it? No? You don't see it? Okay. All right, did we get the same answer for all three methods? Yes, that is correct. Let's move on to number 7. All right, when you get to number 7, remember to make the table to the right of the diagram. Where are we going to make the table? All right, so with that said, we're going to draw 1, 2, 3, 4, 1, 2. First thing you're going to write is name. Second, and this second row, check this out. Look up, please. For this second row, I want you to do automatically Z, and then write impedance. Impedance. Remember when I give you guys the presentation on the different circuits and stuff, how do they come up with those symbols? The only mistake that I saw on some home plates, you are getting mistaken the impedance with the current, and we'll address that right now. All right, with that said, let's start with the name. Tell your neighbor the name of this one by now. Let me zoom in case you don't see it. Yeah, it's the resistor. Resistor, and the symbol is always like that. And one way to remember that is, remember the light bulbs have a little string wire. It has a resistance to so much power, and it looks like that. All right, and what is its impedance? 6. All right. Let's go to this second one. Tell your neighbor the name of this one. Let's see if they remember. Inductor, inductor. And that one is like this. And that's 2 what? I. And remember how I got the symbol? How do they get the symbol? They have a magnet, and I use a pencil, and then you wrap the wire around it, and it just makes the, you know, a magnetic field sometimes, or whatever the case. All right, let's go to the last one. The last one is a capacitor. Symbol, like that, and it's the only one with what? Negative value, negative 10I. And how did they get the symbol once again? The capacitor stops the voltage from going in a certain direction. That's why it stops the voltage like that. That's why that's the symbol. All right. So with that said, current. Look up, please. Current given that one. They usually use the variable I as the current. Make a label that. Because this is where some of you like get confused. So our formula for finding the voltage of each component is V equals what? The current I times Z, which is the impedance. And I said it sounds like a credit card. These, no, these. Nice. All right, so let's find the voltage of each piece. And remember, for each of them, we need to find this. So let's do this automatically. Look up, guys. I'm going to write, for each one of these, let's write V equals, and the first thing you write is your voltage. What is the voltage given? 7.2 plus 9.6I. Write that in parentheses. 7.2 plus 9.6I. 7.2 plus 9.6I. 7.2 plus 9.6I. All right. So according to the formula, we already have this, and this in place. What are we missing? The impedance. The impedance is already written for each one of them. What is the impedance for the resistor? 6. So let's do that one first. 6. Distribute. Therefore, we end up with 6 times 7.2, that's 43.2, plus 9.6I times 6. 6 times 6 is 36. I got 3. 9 times 6, 54, plus 3, that's 57. And that's I, and this is the voltage running through the resistor. So to the next one. The next one is the inductor. 2I, distribute. So 2 times 7.2, that's 14.4, but it's got an I now. All right. 2.1 times 9.6, that is plus 19.2 I squared. All right. However, what's the next step for this one, guys? Underneath the I squared, I want you to write -1. Don't forget to substitute the -1 anytime you see an I squared. And start with this number first. The constant goes first. So what is -1 times 19.2? -19.2. And then at the end, we write the imaginary plus 14.4 I. And that's the voltage for the inductor. All right, bless you. So the last one, the resistance or the impedance is negative 10I. So I write negative 10I, distribute. I end up with negative 10 times 7.2 is negative 72I. Negative 10I times 9.6, that's negative 96I squared. And what do we know about I squares? Negative 1. So we start with this. This becomes what? Positive 96. Negative 1 times negative 96. And we're left with minus 72I. And that goes at the end. That's the voltage for the capacitor. Bless you. So those of you that are going into computers and all that, you're going to be learning a lot of this and doing a lot of that with advanced calculus and stuff. Yeah, let's go. All right, let's see how this looks. Look at that. Humor, right? Bam. All right, let's go to number 8. Number 8. It reads, without solving the equation, state the number of solutions and whether they are real or non-real. Two-part question. So here goes the premise for these. Most important part, it needs to be in standard form. Standard form. What does that mean, guys? Standard form. Then it needs to be from greatest to least power. Let's see, is this from greatest to least? Yes. Now that we have the greatest to least, the second thing is identify I, B, A, B, C. So A, B, and C. Does everybody see? Step number 3, make sure you write your discriminant. Discriminant. And what is the discriminant? B squared minus 4AC. All right? Therefore, parentheses squared minus 4 parentheses parentheses. What goes in here? What is B? Negative 6. What is A? 9. And what is C? 9. Let's see what we get. This is 36 minus 9 times 9 is 81 times 4, 324. Yes. Yes? 81 times 4. Yeah. Subtract, that gives us negative 288. Yes? Or 298? 288? All right. So, let's make a little table here so that we remember what are we looking at. What does the table say? Number that we end up with and the real solutions that we should have. So if we end up with a positive number, we should have 2 real solutions. If we end up with a number 0, we should be at 1 real solution. If we end up with a negative number, what does that tell you? No real solutions. So look at the number that we ended up with, negative 288. Therefore, number of solutions? No real solutions. So question, if they're not real, can we continue with this in order to solve this using the quadratic formula? Pay attention to this one. Using the quadratic formula. Yes, we would end up with something like this, negative 288. What does that mean? That I'm going to end up with a plus minus what? Tell your neighbor what this is, please. I, that is correct. So that means we're going to end up with two imaginary or two non-real solutions. Yeah, you can do either two imaginary and two non-real. Plus minus whatever imaginary or complex. Yes? When you take the square root, how many solutions do we get? Square roots are always 2. Plus, minus. There isn't unless it's imaginary. Let's go to number 9. Number 9. It says, a gardener has 140 feet of fencing to put around a rectangular garden. The function A of W equals 70W minus W squared gives the garden's area in square feet. Does the gardener have enough fencing for the area of the garden to be 1,300 feet? So, the first thing we do is we rewrite this one, look up, but instead of writing A of W, we write the area given, which is what? 1,300. So let's do that. Let's do 1,300 equals 70W minus W squared. All right? So here we need to set it equal to 0 so we can start trying to see what we have. So we subtract 1,300, subtract 1,300. We end up with 0 equals, let's write this in standard form. What do I start with? Negative W squared, then plus 70W, and then negative 1,300. All right, this one is just like the one we just did over here. Let's try and see if we can have any solutions before we do any other work. Because if there's no way of solving this, then why are we going to substitute values in there? So, what do we need to do? Identify what? A, B, and C. And let's see if there's any solutions. B squared minus 4AC. So we substitute 70 for B, minus 4 times negative 1, because that's A. And C is negative 1,300. All right, what is 70 squared? 4,900. Negative times the negative is a negative, positive times the negative is a negative. 4 times 13, that's 5,200. So what is 4,900 minus 5,200? Negative 300. Tell your neighbor what this number means. What does that number mean? That there's no real solution. So are we going to substitute the 140 to continue doing the work? No, because automatically we know that there's no solution to this equation. Let's go to number 10. What's that? To have what? Oh, my bad, yeah. Our statement. Answer the question. It says, does the gardener have enough fencing for the area of the garden to be 1,300? The gardener doesn't have enough to fence the area of 1,300 feet squared. Thank you. All right. Let's move on. Let's go to number 10. Now, this we've been doing on the warm-ups for the past 2 weeks. You should be able to do this one by yourself, but here it goes again. It says, graph the circle after writing the equation in standard form. Who noticed that on the warm-ups I didn't say graph the circle, I just said what? Graph, because I want you guys to get used to in your noodle to identify equations that are for circles. How do we know that they're for circles? Because it has a what? X squared and a y squared. All right, so here we go. Let me zoom in. First, we need to write it in standard form. How do we do that? We need to get rid of the constant. So what is my constant? 25, so I subtract 25, subtract 25. I end up with negative 25 on this side. For this side, I'm going to rewrite it, but I'm going to rewrite like variables. Variables that are the same kind. So what are the same kind? X squared and x. So I'm going to write those in parentheses, x squared plus 6x. And I'm going to leave an empty space there for the trinomial. Plus, what's my other one? Y squared and negative 10y. Y squared and negative 10y. Leave an empty space for the trinomial. Why are we leaving that empty space? Because we need to complete the square. How do we complete the square? We take b, which is what? I'm going to show you the steps just for those that are not here for the sake of them. b is what? 6 divided by 2 squared. And over here is what? Negative 10 divided by 2 squared. Therefore, I write it over here also, 6 divided by 2 squared plus negative 10 divided by 2 squared. All right, let me simplify this. This ends up being x squared plus 6x plus 9 plus y squared minus 10y plus negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Therefore, this is negative 25 plus 9 plus 25. All right? Therefore, at this point, I'm going to simplify this side. This cancels this. We're left with 9 equals, and let's factor this. Since we know they are what? Perfect square trinomials, we can use the shortcut, which is square root and square root. So this is x3. What is the sign of the middle term? Positive, and we write that squared. Plus square root, that's y and 5. Sign of the middle is a negative, and we write that squared. Do we have our standard form? Yes. Can we find our center now? Yes. Center. What is h, everyone? Negative 3, that is correct. And what is k? 5. All right, we need a radius. Our radius, we take the constant and square root that. And what is square root of 9? 3. So basically we take this, take the square roots, and that's how we find our radius. So we have that. All right, let's graph. Negative 3, 5. Negative 3, 5, which is right there. And my radius is 3 steps in all directions. So I go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. One, two, three, 1, 2, 3, yeah. It's kind of weird, huh? Let me redo it again. What's that? Nice. There it is. A lot better, yeah? All right. Number 11. It reads, find the equation of the parabola with a vertex of 0, 0. So here they give us the vertex going through the point of origin. And it says, given the focus and directrix, but now they want us to actually graph it. And for this one, we do need 2 exact points after we graph those points. So let's start with the vertex. The vertex is going through what, everyone? 0, 0. So plot your point at 0, 0. Next, with red, I usually use for the focus. What is our focus? 0, 2, which is right third. What is our directrix point? Our directrix point is y equals, oh, my bad, I got this one wrong. It goes right there. Yeah, I did that to see if you were paying attention. All right, our directrix is y equals -2, which is right there. And what does that mean? It's a dotted, invisible line going through that point. So how does that help us, Mr. Q? It helps us to picture that our parabola is going to go away from the directrix. That means it's pointing up. Is that correct? Yes, Mr. Q. And it's crossing through the point of origin. However, now I need an equation for this. If the parabola is going to be opening up, what does that look in regards to variables? It's what? X squared. When it's parabola opening up, it's what? X squared. And what does that equal to? Who remembers? 4 P and Y. That is correct. All right. So let's substitute for the value of P, and it's usually our focus. What is our focus here? 2. That goes in here. So we substitute 2. So I bring down x squared equals 4py. So it's x squared equals 8y. Now that we have our equation, now I need 2 points in order for me to graph my parabola, aside from the one of the point of origin. So let's do this. Let's do x, y. All right, so we can start with -2. However, I'm going to move it 1 over and start with -4. Yeah? All right, so let's substitute -4. So let's see. Instead of x, what am I going to substitute? Everyone? -4. So it's -4 squared equals 8y. What is -4 squared? 16 equals 8y. So that means if we divide by 8, divide by 8, what is y? 2. But since it's a parabola, do I need to use work to show the other side? No, but what number do I need to use? If I use -4, that means over here I need to use what? 4. And what is that number in y? 2. That is correct, because it's a parabola. All right, let's plot these 2 points. -4, 2, +4, 2, and our parabola is right there. Look at that beauty. All right, now the question came up, look up guys, the question came up, if it was pointing downward, would I use a different formula? No, it's still in x squared. So I would write what? X squared equals 4py, and with the values it's going to become a negative radical, whatever the case. I mean a negative parabola. So Mr. Q, when do we write the y squared? When the parabola is neither down or up, it's like this or like that. That's when we use the y squared. So help me finish this one. If it was sideways, what would I write? Y squared equals what? 4px. That is correct. Number 12. And then we'll stretch. Give me a second. It says, solve each linear quadratic system algebraically. This is a system we can use by substitution. Which of the 2 equations seem easier to manipulate? The top one. So let's leave y by itself. So we do what? -2x minus 2x. We got y equals negative 2x minus 2. All right? So, what does that tell us? That y is what? Negative 2x minus 2. So, in this second equation, what do I substitute in here? That is correct. Negative 2x minus 2. Bring everything else down to plus 3 equals 2, parentheses x minus 1 squared. Let's combine stuff. Negative 2x plus 1 equals 2. And let's expound this. This is the same as x minus 1 times x minus 1. You do the multiplication. X times x times negative 1. Negative 1 times x, negative 1 times negative 1. So once you do the multiplication, bring it back over here, and we write what? X squared, what else? Minus 2x plus 1. All right. So in order to solve the quadratic equation, it needs to be equal to what? 0. So we bring everything over here, or this one over there? What do you guys want? Everything from over there to over here. So I do what? Plus 2x minus 1 plus 2x minus 1. 0 equals x squared. And that's it, right? Yep. These cancel. And my last step, square root, so 0 equals x. Can you remember what we're going to do with that value, please? Very good. Substitute that into this linear equation, so like that we can solve for y, because it's a system. So we write y equals negative 2 times 0 minus 2, y equals 0 minus 2, y equals negative 2. Am I done? No, we need to solve. What does that mean? We need a coordinate. What's our coordinate? 0, negative 2. Solution. Question. If I was to graph these two, what does this point mean? Tell your neighbor, what does this point mean? All right? That was number 12. I'm going to go ahead and stop part 1 of the video right here, and I'll continue with part 2 as soon as we take a little break.